Alright, so now that we know about scale factors and ratios and proportions, we can apply that knowledge to triangles. And we can prove that triangles are similar in similar ways that we did to last semester when we did congruent triangles. So let's take a look. So similar triangles. The same, but not quite. Triangle similarity and triangle congruence are almost the same thing. That's a big almost though. Congruent triangles have the same size and shape. And similar triangles have the same shape, but they have different sizes. So triangle similarity also has DNA tests. Just like congruence had SSS, SAS, ASA, and etc. to tell whether or not they are in fact similar. For similarity, they are AAA, AA, SAS, and SSS. We will of course go over these now and explain the difference between them and their congruency counterparts. So first is SSS. This means if all three sides of two triangles have the same ratio, then the triangles are similar. So I need three ratios to be the same between two triangles. So let's take a look and see. Here we have the sides matching up that we've been working on, the corresponding sides. DF matches up with AC. And the ratio there is 2/4, and if we reduce that it turns into 1/2. The next side is DE, and DE matches up with AB. The ratio there is 3/6, or 1/2. And then finally the last one is 4/8, EF over BC. And again, the ratio when you reduce it is 1/2. So since all three pairs of sides are proportional or the same ratio, you can say that triangle ABC is similar to triangle DEF. And the reason is SSS. Again, this symbol, the little tilde, means similar or similar to. So this is similar to what we did last semester with congruence, but instead of the sides being the same, we need the sides to be proportional. The next method we can use is SAS. So SAS means that if two sides of two triangles have the same ratio, and the angle between the sides is congruent, then the triangles are similar. So we have SAS, two sides have the same ratio, and then the angle between. Remember the A is sandwiched in between the S's, so the angle has to be sandwiched in between the sides that are proportional. So again, you can compare the sides that we have in these two triangles. We have DF with AC, so the fraction there would be 2/6, and you can reduce that to 1/3, with DE and AB. And DE is 3 and AB is 9, so if we reduce that, that's 1/3. Notice that the angle in between the sides is also congruent. A to D is congruent. So because you have the two pairs of proportional sides and congruent angles, you can say these triangles are congruent by SAS. So I can't stress enough that the angles that are congruent must be between the sides that have equal ratios. If not, you get ASS, and that spells that bad word. And its backward evil twin, SSA, and they don't work for similarity either. The final piece is A's. You can have a triple A or double A to prove triangles are similar. So if all three angles of one triangle are congruent to all three angles of another triangle, then the triangles are similar. But what about AA? Well, if you have two angles inside a triangle, can you not solve for the third angle because their sum is 180? Of course you can. So having two angles is the same as having three angles for similarity. I like to always use double A, but sometimes we will see people use triple A. It is unnecessary, but I thought I would warn you. So let's see this one. If you can show that two triangles have the same angle measurements for two of their angles, then by definition those triangles are similar. So again, looking for the markings. C goes with F, B goes with E, and A goes with D. You only need two angles to prove that triangles are similar. So let's try the practice problems on the back. So for each pair of triangles, you're going to determine if it's similar or not, and then you're going to list or bubble in the answer A for SSS, and you bubble it on the bottom, B for SAS, or C for AA or AAA, or D for not similar. So let's try the first one. Match up your corresponding sides. So I have 12/4, 9/3, and 15 over 5. I want to make sure that these give me the same ratio, so let's make sure I reduce them and see what they give us. Okay, so taking our calculators and doing 12 divided by 4, I get 3. Doing 3 divided by 9, 9 divided by 3, you also get 3. And then 15 divided by 5 is also equal to 3. So because the ratios between the sides is the same, you can say this is similar by SSS. So then you would bubble in letter A on the bottom. Okay, let's try one more and I'll let you do the other 2 or other 4 on your own. Here we have corresponding sides and a congruent angle. So it looks like it might be SAS, but we have to prove it by using the ratios of the corresponding sides. So this side 3 matches up with the 12. And the 4 matches up with the 16. So let's see what that scale factor is, or that proportion, that ratio. 3 divided by 12, enter. Then hit math and then fraction for 1/4. So this fraction reduces to 1/4. Let's try the next one. 4 divided by 16. Math, frac. That also reduces to 1/4. And since the angle is in between, these are similar by SAS. So I could bubble in letter B down on the bottom. For this triangle, all I'm looking at is my angle markings. Remember, one method of proving triangles similar is if 2 of their angles are the same. So taking a look, angle O matches up with angle R, and angle M is matching up with angle P. So because you have 2 pairs of angles that are congruent, you can say these triangles are similar by AA. Try the last 3 problems on your own and see if you can prove those other triangles similar.